Hi there. We're Coast to Coast Engineering. We offer a wide variety of civil engineering disciplines, and today we'd like to show you our recent project on the North University Fire Station 50. Let's take a look, shall we? Carlos, why don't you lead it off?
Thank you, Jake. For the site civil engineering portion of the project, I will talk about the design approach, the findings, and the results for the site layout, the grading, and the utility design. Site layout. For the site layout, we decided to take advantage of the right-of-way that was provided for the project, approximately 1 acre of land, and use most of the space to avoid congestion. One of the most important features of our layout is a one-way drive-through for the fire engines, entering from the cul-de-sac on Shoreline Drive and exiting onto Noel Drive. Modifications to the street layout will be later discussed by our transportation engineer, Matthew Bruno. Grading. The grading was based on the existing conditions of the site. The entrance to the fire station is approximately an elevation of 300 feet, and the exit onto Noel Drive is approximately 316 feet. The grading of the surface where the fire station building will be built is a level surface with a consistent slope running towards the southwest. To accommodate for the difference in elevation at the entrance and exit of the fire station, a retaining wall will be designed to allow the creation of a ramp from the main surface of the building onto Noel Drive. The design of the retaining wall will be later discussed by our structural engineer, Alexander Rangel. Utilities. The design of the utilities for the fire station included the construction of water service lines, sewer laterals, and storm drain lines. The storm drain lines calculations were made by our hydrology stormwater engineer, Guillermo. The locations of the lines were designed to collect water, follow the grading of the site, and exit onto the street where the existing storm drain water inlets will collect the runoff. The connection to the existing sewer lines and water lines were designed by our water resource engineer, David Klein. The connection to the existing utilities will be very straightforward. The connection to the water lines, which runs under the Noel Drive, were proposed on the north side of the site. This was also the case for the sewer lines. This was the results for the design of the site civil services from Coast to Coast Engineer. Now our transportation engineer, Matthew Bruno, will talk about our transportation design. Matt?
Hi, my name is Matthew Bruno, and I am the transportation engineer for this project. I will be explaining my AutoCAD exhibits I drafted for the North University Fire Station 50. My first exhibit is the driveway construction detail. There are two proposed driveways for this site, one located in the cul-de-sac on Shoreline Drive and the other on Noel Drive. Both are dimensioned to be 30 feet wide, which will allow plenty of room for the fire truck accessibility. Second, I have my median improvement detail. I made a profile view of the existing median showing the original ground of the road and the finished ground of the median. I labeled the location where the median would be cut to allow the fire trucks easier access to the westbound side of Noel Drive from the driveway. The spacing of the accessway will be 32 feet wide and only available for the fire department. Next is the parking detail. The site will have a total of 15 spots to accommodate the 10 crew members and any guests that are visiting. The parking spots are ADA approved and will be dimensioned per SDM 117 standards, 18 feet long and 10 feet wide with 4-inch wide thermoplastic markings. Last, I have the sign and striping detail. It shows the locations of the proposed signs that tie in with the new fire station and also the existing signs in the area that will be protected in place. The proposed signs are in black and existing is in gray. The existing striping will also be protected in place. That concludes my transportation segment. Next we have Alexander to talk about the foundation and retaining wall.
Hi, I'm Alexander and I was in charge of designing the retaining wall and the foundation for the fire station. The retaining wall was designed to facilitate construction of the access ramp to Noble Drive, and the foundation was designed to be able to withstand the vertical loads and lateral loads of a two-story light frame building with a cantilevered balcony. The retaining wall's height was determined to be at minimum 6 feet high. However, a 9 feet retaining wall was used to account for the depth. The other dimensions of the wall were determined through calculations. Two equations were developed to facilitate the determination of the thickness and reinforcements needed in each section of the retaining wall. Once I had both equations, I was able to design the stem of the cantilevered retaining wall, choose the width to prevent sliding, which was 17 inches, check for overturning, check for bearing, designing the heel with a 12-inch thickness and number 6 bars at 10 inches, and finally designing the toe with the resulting of 2 feet of length from the stem and number 3 bar reinforcements at 10 inches. The foundation was designed according to the loads that were calculated using 8 columns within the building perimeters and 2 columns outside of the perimeter to support the cantilevered balcony, a slab on grade, and a continuous concrete footing around the perimeter to support the building. And here is Guillermo, who will present the hydrology storm study.
And now for the hydrology portion for this project. As you can see, the existing storm drain areas are defined as drain area 1, drain area 2, drain area 3, with the different Q100s labeled accordingly. With this, we use the San Diego County Hydrology Manual and we use the rational method to use the intensity duration design chart to calculate the different Q100s and to use these values to go ahead and propose the storm drain inlet size as well as the storm drain pipe and the storm drain inlet sizes. With that, we can see in this next image that we are using the typical curve in the SDR-SD type A for both proposed type inlets. And then as well, we calculated the proposed Q100s for the different drain areas, whereas drain area 1 is 0.83 CFS, drain area 3 is 3.6 CFS, and drain area 2 is 0.9 CFS, with 3 different biofiltration basins that will go ahead and meet all the outstanding BMPs for stormwater.
Hey there guys, I'm James and I did the geotech evaluation for this project at North University Fire Station 50 for Coast to Coast. I'd like to show you how we figured out what kind of soil we were working with. So what I did is I went to the data basin website where you can look up a location in San Diego County. And so what I did is I looked up the Shoreline Drive and Nobel Drive where our project is. And what you can do is you can add the layer that shows all the different soils, use the identify tool to click on that different color and it will show you what type of soil you have. So here we have Huejero loam, which is a non-corrosive and non-expansive, which is perfect for working on our site. And by knowing what type of soil you have, you can look up different properties of that soil, which can tell you the bearing capacity and other sorts of useful things for geotechnical evaluation. Next, I'd like to show you one of our boring logs. So here, if we scroll down on the report, you can see the filled out boring log where the topsoil for the first 3 feet is mostly containing some types of organics and dry, dark brown soil that's poorly graded. But about 3 feet underneath, you'll get mostly the Huejero loam that is presented on data basin. It's clay-like, it doesn't corrode well, it doesn't expand too much. It's a reddish brown color, and these are the type of comments you'll see on a boring log. And then when you get past 20 feet, you have to make an assumption because the drills don't go too much farther. And so we can assume that the Huejero loam is just mixed with more sand, and the sand also has a low expansion risk and negligible water content, so it's not going to be a problem for our site. And with this information we can work more on the foundation calculations. Next, I'd like to pass it off to David, our PM, who's going to full send it.
Hello, David Klein here. I was in charge of both the water and wastewater studies. First, I will summarize the key components of the water study using the water's exhibit as a visual. Fire Station 50 will tap into the 12-inch EVC main that runs down Nobel Drive, as seen here. Using the city's design guidelines, the calculated demand flow for this fire station was 26 gallons per minute. Based on this demand flow, I chose a 2-inch PVC water service line, as seen here in the exhibit. We also included a pressure regulating valve to lower the pressure from 130 psi in the main to the maximum 80 psi established by the city's guidelines. Fire demand was determined to be 3,000 gallons per minute, which both mains bordering the site could handle. The 10-inch AC main, as seen here on Shoreline Drive, was selected to connect a new fire hydrant, as seen here, in front of the fire station. For wastewater, we first investigated the existing 8-inch PVC sewer main that runs down Nobel Drive, as seen here. We used the City of San Diego Sewer Design Guide to calculate a design flow capacity of 322 gallons per minute. Next, we used those same guidelines to calculate a demand flow for the project of 39 gallons per minute. Beginning with the city's minimum requirements for sewer lateral design, we picked a 4-inch lateral on a 2% slope and calculated the flow capacity using Manning's equation. These parameters resulted in a flow capacity of 105 gallons per minute, more than enough to satisfy the demands for this project. The sewer lateral, seen here, connecting to the sewer main. On will now review the construction scheduling and cost estimate.
Hi, my name is An, and I will be talking about the construction aspect of the projects. The North University Fire Station 50 is a special project to cover 16,000 square feet, and the station will accommodate 10 crew members, including 2 fire captains, 2 fire engineers, 4 firefighters, and 2 paramedics. The station will include 3 apparatus bays for the fire engine and ambulance, dorm rooms, kitchen, washroom, ready room, station alerting system, and also training classroom. After researching and analyzing the materials and unit costs, we conclude that the cost estimate for the Fire Station 50 projects will be $10,700,000. To break down the cost estimate, we will spend $1 million on engineering and design services aspect. A big portions of our budget will be spent on the actual construction services, which is roughly $8 million. The rest of our budget will cover any fees, exterior, interior equipment, maintenance, and monitoring programs. The first phase will be identifying project constraints and preparing design. This can take up to 200 days to complete architectural design, prepare advertising package, prepare a bid and award contract. The next phase is the actual construction. This phase will take up to 400 days to complete, and this will cover foundation building, exterior and interior construction, and inspections for the project. We have also designed a proper schedule for this project. Our team will begin planning the projects on May 2nd, 2018. The project is estimated to take 600 calendar days to complete. By December 23rd of 2019, the projects will be complete and ready to use. The first phase will be identifying the project constraints and preparing design. This can take up to 200 days to complete.
Thank you for coming on this ride for the North University Fire Station 50 plans. We've been coast to coast, and you've been fully sent.